So in each of these pictures, so let's say the first one, if I ask you to find the local maximum and local minimum, you might say, hey, this point is the local max, this point is the local min, right? That is true. What if I ask you to find the absolute maximum and absolute minimum of a function in a closed interval? So what is absolute maximum? Absolute maximum is I am looking for a point that has the highest, the largest y value. Absolute minimum is I am looking for a point that has the smallest, the lowest y value. So in the first picture, where is the highest y? This point has the highest y, right? So this one is the absolute maximum. And then this is absolute minimum. What about this point and this point? This is not an absolute max, and then this is not an absolute min. What about the second picture? Where is the highest y? So the highest y in a closed interval. Oh, by the way, why do we have to use a closed interval? What is a closed interval? Closed interval means using the first picture, the function starts at this point and then ends at this point. I am not using an arrow. If you use an arrow, that means the function extends all the way up. If you use an arrow right there, that means the function extends all the way down. But that is not the case. In this when we are talking about absolute min and max, we are considering a closed interval only. All right, closed interval. So in the second picture, where is the absolute maximum? So this is the highest y, this is the highest y. So they are both absolute max and then absolute max. And then what about absolute minimum? Is this an absolute minimum? The end point? No, that is not. This one is the lowest y, so this is the absolute minimum. What about this picture right here? Where is the highest y? The highest y is in here and here, right? So they are both absolute maximum. And then what about absolute minimum? The lowest y value. This is the lowest y, this is the lowest y. So they are both absolute minimum. And then the last picture, the highest y. So these 2 points are the highest y. So they are absolute max. And then where are the lowest y? This is the lowest y, so this is the absolute min. So this is how you determine the absolute max and min if you have a picture. What if you don't have a picture? If you don't have a picture, then you have to follow a procedure to find the absolute extrema. So I have 5 functions for you. I want to find absolute extrema. Extrema means absolute min, absolute max. So what's the strategy? First, you have to check the problem to make sure they gave you a closed interval. Closed interval is this. Closed interval, square bracket, square bracket. So that means I don't care about the function when x is greater than 4. I don't care about the function when x is less than when x is less than 0.2. So number 1, we have f of x equals to x plus 1 over x, right? So the closed interval is from 0.2 to past the 4. So first thing is we have to find the derivative. I've explained why in a minute. So f of x is equals to 1, and then this is x plus x to the -1, right? So we bring the -1 down, minus -1 minus 1 is -2. So we have 1 minus 1 divided by x squared, that is set to be equals to 0. And then you solve for x. So this one I do a common denominator, x squared. This is x squared minus 1 is equals to 0. So the only possible way is not making x equals to 0. The only possible way is we have to let the numerator equals to 0. So x squared minus 1 is equals to 0. Factor that, x plus 1, x minus 1 equals to 0. So we have x equals to -1 and x equals to 0 to be my critical number or critical value. Critical number. And then what about x equals to 0? X cannot be equal to 0 in the first derivative, right? So now look at the critical number. Do I need both critical numbers? Do I? Oh, well, why do I write a 0? This is x equals to 1 and x equals to -1. Which one doesn't satisfy the interval? The answer is -1 doesn't satisfy the interval, right? Because -1 -1 is not in the interval. I am looking for 0.2 to pass, therefore I don't need -1 at all. All right, so we have, and then the next thing, what is the next thing? Should I drop them on a number line and then test the test interval? The answer is no. All you have to do is you are looking for the highest y and the lowest y, right? So we are looking for the highest y and the lowest y. Okay, here is how we are going to do it. So we have x equals to what? 0.2 and then 1 and then 4. All we have to do is we plug that in to the given function to find the highest y and the lowest y. So we have to find f of 0.2, f of 1, and f of 4. So when x is equals to 0.2, we plug it into the given function. How come we don't plug it into the derivative? The answer is we are looking for a location, the location of a point. So that's why we need to ask function f, not f prime. So we have 0.2 plus 1 divided by 0.2, that is equals to 5.2. And then f is equals to 1, 1 plus 1 divided by 1, that is equals to 2. And then f equals to 4, 4 plus 1 divided by 4, you need the decimal, right? Because we have to make a comparison. Where is the biggest, where is the smallest? So this is the maximum, right? And then this is the minimum. I only need the biggest y and the smallest y. So it turns out that 0.2 comma 5.2 comma 5.2 is my absolute max, and then 1 comma 2 is my absolute minimum. All right, so you might ask me, hey, you are only looking for the highest y and the lowest y, right? So why don't you just test the left end and the right end? Why do we still need to find the first derivative? Why do we still need to do this derivative? The answer is, so if you go back to this picture, this one is the absolute minimum, right? At this point. So this one is the absolute minimum. You also need to take care of the derivative, because when you consider the slope is going down and then horizontal tangent and then going up. So that means I am saying that a point, okay, so we have a function, we have a curve, and then we have a point. This point can be the absolute minimum. This point can also be the local minimum. So a point can be absolute minimum, also a local minimum. So that's why we have to consider the derivative as well. Because other than considering the left end and the right end, we also need to consider the critical point. Because when you have a increasing that creates a min, decreasing that creates a max, this can be the local and the absolute extrema. So that's why we have to consider the derivative. So overall, the procedure of finding the absolute min and max is you find the first derivative, right? And then you set that equals to 0. And then you find the critical number. And then you test the endpoint. And then you test the endpoint. Also, you test the critical number. Okay, so no sign chart is necessary. Okay, we don't need sign chart, we don't need any test interval. Just do the derivative, set that equals to 0, find the critical number, and then you test the left end, the right end, and the critical number to find the highest y, the lowest y. So that's all you have to do for absolute extrema. So moving on to the next problem. So the next problem, we have this. We have f of x, number 2. We have f of x equals to x divided by x squared minus x plus 1, and then the closed interval is from 0 to 3. So I only consider the x value between x equals to 0 and x equals to 3. So this one, the first derivative is a quotient rule, right? So I'm going to skip that. I leave the quotient rule for you because this section is not about discussing how to use a quotient rule in derivative. So the derivative is equals to x squared minus x plus 1 squared, and then the top is 1 divided by x squared. So when you do this work, I expect you to use the quotient rule to take the derivative. Make sure you get the same thing. You have to simplify all the way to the end. And then you set that equals to 0, and then immediately the top must be equals to 0. So 1 minus x squared equals to 0. Factor that, you have 1 plus x, and then 1 minus x equals to 0. All right, and then you solve for x. So we have x equals to 1 and x equals to -1. Which one should I omit? Look at this. From 0 to 3, we do not include any x value, right? So, sorry, we do not include any negative value. So this one must be omit. And then x equals to 1 is my critical number. All right. And then we also have to consider the parabola. Can the parabola be equals to 0? The x squared minus x plus 1. So if you graph this parabola really quick, this is a parabola that is above the x-axis. That means this is always greater than 0, and this is never equals to 0. So there is nothing to worry about the denominator. All right, so what do we have to test? We have two endpoints and then one critical value. All right, so and then we have to test f of 0, f of 1, and f of 3. How come we are not using f prime? Because we are not considering slope. I am looking for location. I am looking for an order pair x comma y. I need the highest y to be my absolute max, the lowest y to be my absolute min. So 0, we have 0, 0 square minus 0 plus 1, then we have 0. So this is, okay, we can't decide this yet because we still need to compare that to the other two y values. 1 divided by 1 square minus 1 plus 1. So that is 1 over 1 equals to 1. And then this is a 3 divided by 3 square is 9 minus 3 plus 1. That is equals to 3 over 7. So this is the highest, right? And then the lowest is 0. So that means 0 comma 0 is an order pair. So that is my absolute min. And then 1 comma 1, an order pair. This is my absolute max. Okay, so that is number 2. Moving on to number 3. It's a pretty long problem. Number 3, you have f of x equals to 2 cosine x plus sine of 2x, and then the closed interval is from 0 to half pi. All right, so first let's find the derivative. So A, we find the derivative, and then B, we do the plug-in, right? So f prime of x, that is the derivative of cosine is negative sine. And then we have to use a chain rule, right? The derivative of sine is cosine 2x, and then times the derivative of 2x, we get a 2. Okay? And then we have to set this equals to 0. And then solve for x. We have a cosine 2x and a sine x. We can do the work like this. In order to solve a 0, either you work with sine only or you work with a cosine only. So since there is a cosine 2x, I can use a double angle formula of cosine to get this in terms of sine. So we have negative 2 sine x and then plus 2 cosine 2x. If you don't remember this, look it up online. Cosine 2x has a 3 double angle formula. One of them is 1 minus 2 sine square x. All right, and then you distribute the 2, and then you factor the quadratic equation. So we have negative 2 sine x plus 2 minus 4 sine square x equals to 0. I let the square go first. So that is sine square x minus 2 sine x plus 2 is equals to 0. And then when I do factor, I don't want the leading coefficient be negative. So to take care of that, I'm going to factor out a negative 2 from the entire expression. So that is 2 times sine square x minus sine x minus 1 equals to 0. Do you know how to factor this? 2x squared minus x minus 1. So this is equals to what? That is equals to 2x minus 1 and then x plus 1, right? Okay, so we have a negative 2. And then we have 2 sine x minus 1 and then a sine x plus 1. Use any factor technique you want, equals to 0. So to take care of the negative 2 right here, all you have to do is divide both sides by negative 2. So we have to set each factor equals to 0. So 2 sine x minus 1 equals to 0. We have sine x plus 1 equals to 0. This is sine x equals to 1/2. And then this is sine x equals to negative 1. All right. And then sine x equals to 1/2, and then x must be from where to where? From 0 to pi over 2. We only consider x goes from 0 to pi over 2. So look at your unit circle. From 0 to pi over 2 is 90 degrees, right? From 0 degree to 90 degrees, that means within the first quadrant. How do you find that the y value is equals to 1/2? The answer is you have x equals to pi over 6. That is one of the critical number. From 0 to pi over 2, unit circle in the first quadrant. All right, and then sine x equals to negative 1 in the first quadrant. Can x be negative? The answer is no, because that means this one has no solutions. I'm not saying that is no solution. This one has no solution within 0 to pi over 2, because in the first quadrant, y can never be negative. So we only have one critical number. So we have 3 numbers to test: the pi over 6, the left end, and the right end. So we have to test f of 0, f of pi over 6, and then f of pi over 2. This is my favorite problem on the test because I can push people to do a lot of trigonometry. So you have to plug it into the original function. So 2 times cosine x, and then plus sine of x, 2 cosine pi over 6, and then plus sine of pi over 6, and then 2 times cosine pi over 2, and then sine pi over 2. Cosine 0 is equals to 1, right? So we have 2 times 1 sine of 0 is 0, so that is equals to 2. And then cosine pi over 6, so look at your unit circle. What is the coordinate of pi over 6? The coordinate of pi over 6 is root 3 over 2, comma 1/2, right? And then what about pi over 2? 90 degrees. X is equals to 0, y is equals to 1. So this one, you don't really need to recall this from the unit circle. This one, all I want you to do is use your calculator. So if you are using your calculator, because this one we don't want the exact value, I need a decimal in order to give me a better sense when I do comparison. So when you do this in your calculator, you use radian mode. How do you set your calculator to be in radian mode? Every scientific or graphing calculator has a mode key. So you have to press the mode key and then make sure the mode is in radian. So we use in radian mode in this type of problem. We use degree mode when we solve an application problem. So 2 times cosine pi over 6 plus sine pi over 6. So if you do your math right, this is approximately equals to 2.6. And then 2 times cosine is x coordinate, right? And then sine is y coordinate. So this one is 2 times 0 plus 1, that is equals to 1. So which one is the highest? This one is the highest, right? And then this one is the lowest. So that means pi over 6, comma 2.6. Again, this is no longer an interval. This is an order pair x comma y. So that is my absolute max. And then pi over 2, comma 1, that is my absolute minimum. All right, so that would be number 3. Let's take a look at number 4. So number 4, we have f of x equals to ln x squared plus x plus 1, and then the interval is from -1 to 1. All right, so first we take the derivative. Okay, good practice. What is the derivative of ln? Ln is 1 divided by everything inside ln, x squared plus x plus 1. Are we done? No, we have a quadratic function within a natural logarithm. So using chain rule, we have to take the derivative of x squared plus x plus 1, which is equals to 2x plus 1. All right, and then we set the whole thing equals to 0. So the 2x plus 1 goes to the top. That means the numerator, 2x plus 1, equals to 0. So we have x equals to negative 1/2. This is a critical number, right? Because negative 1/2 is between negative 1 and 1. All right, how about the bottom? X squared plus x plus 1, right? So this one, you square the x itself plus x plus 1 is always greater than 0. So this one doesn't give me any critical value. So you can't, when you set that equals to 0, there is no such x value because this is a parabola above the x-axis. So therefore, we have 3 numbers to test. The lower limit, actually you can call this the lower end, the critical number, and then the right end. So that is equals to ln. ln of what? Let's see. ln, the square of negative 1 is 1 minus 1 plus 1. So that you have ln1. ln1 is equals to 0. This you have the square of negative 1/2, that is 1/4 minus 1/2 plus 1. This you use your calculator. You get around negative 0.29. And then the last one, you have 1 plus 1 plus 1, ln3. So that is around 1.10. Which one is the smallest? So this one is the lowest, and then 1.10 is the highest. And then we draw our conclusion. So the point x comma y equals to negative 1/2 comma negative 0.29. This is my absolute min. And then on the other point, 1 comma 1.10 is a point on the curve of the given function. This is absolute maximum. That is number 4. Let's take a look at the last one, number 5. So number 5, we switch color again. So number 5, we have f of x equals to x minus 2 times inverse tangent, which is also known as arctangent of x. The interval is from 0 to 4. First, you take the derivative. F prime of x, that is 1 minus 2. What is the derivative of inverse tangent? You have to look up the formula. The derivative of inverse tangent, the derivative of arctangent is 1 divided by 1 plus x squared. And then you set the whole thing equals to 0. All right, so let's toss the 2 to the other side. We have 1 equals to 2 divided by 1 plus x squared. And then we multiply the denominator on both sides. 1 times the denominator, which is just 1 plus x squared, is equals to 2. And then we have x squared equals to 1, and then x is equals to 1 and 1 and negative 1. All right? Why? Because when you take the square root on both sides, you have plus or minus the square root of 1. Why plus or minus? Because this degree is even. 2nd degree, 4th degree, 6th degree, 8th degree, 10th degree. As long as the degree is even, when you take the radical on both sides, you have to consider the plus or minus. Besides, negative 1 squared is equals to 1, right? And then which one we do not need to consider. So since the interval is from 0 to 4, then we do not consider negative 1, because negative 1 is not in this closed interval from 0 to 4. We do not consider any x value when the value is less than 0. So this is my only critical number. So we have 2 numbers to test. We have to test f of 0, f of 1, and f of 4. All right, let's do the test. We plug it in. So we have 0 minus 2 times inverse tangent of 0. And then 1 minus 2 times inverse tangent of 1, and then 4 minus 2 times inverse tangent of 4. So this one, make sure your calculator is in radian mode. This one I got a 0, this one I got a negative 0.57, just an approximation. This one I got a 1.34, so this is the highest, of course, and then this is the lowest. All right, and then you draw your conclusion. So we have an order pair x comma y that is equals to 1 comma negative 0.57. This is absolute minimum. And then we have 4 comma 1.34. This is my absolute maximum. So that's all in this absolute extrema exercise. If you think my video is helpful, please click the like, subscribe, share my video out on social media. I appreciate that really, really much. I see you all in the next one.